Hey, guys, please settle down. We're about to start. Okay, next up, John Frizzell, and the topic is from Monolith to Microservices in 10 steps. There you go.
Thank you very much. Okay, good afternoon. Can everyone hear me okay? Okay, I'm going to take silence as yes. So my name is John Frizzell. I'm platform architect with Red Hat Mobile. Joined Red Hat in 2014 as part of an acquisition of a company called Feed Henry, and had been working with them since 2008 on a mobile application platform. So just want to get a bit of a feel for the type of audience we have. So how many people are familiar with the term microservices and feel they know what it means? By show of hands? Most people. Okay, good. How many people are actually implementing a microservices architecture or have played with microservices? Okay, just about half. And how many people are doing microservices, proper microservices architectures in production today? Okay, about what I expected. Very good. Okay, so a little bit of background. So 2008, we started with a single Java monolith. And that's what we had up until about 2011, when we started looking at Node.js as an alternative technology. Got really excited about Node.js, and we thought, hey, this would be really cool for microservices. So let's go and build some Node.js microservices. We went off for about a year, and we came back with a Node.js monolith. So then we had a Java monolith and a Node.js monolith, and an incredibly symbiotic, codependent relationship between the two of them. So we learned a little bit from that. We moved on 2013, 2014, 2015, and actually did some proper Node.js microservices. But they were still very much sitting behind these monoliths and only really doing small pieces of functionality. So last year, we figured we'd learned almost enough to really tackle the monoliths and say, right, it's time to kill the monoliths and really move to a microservices architecture. So this is the story of the journey that we are on. We haven't finished the journey. I can't say whether it will be a success or not, but this is the journey we're on. So first off, why do we want to kill the monoliths? What's the problem with them? So typically with a monolith, you're looking at horizontal tiers. You have your UI layer, your business object layer, and your database layer. And that doesn't really represent a system very well, because any piece of functionality you want to add, any new feature, typically has to be added at all three layers. So even though you separate horizontally, you're touching all of the layers almost every time you want to do anything. So you pretty much have them tightly coupled. With the monoliths, you end up with a very large code base. It's difficult to keep in your head the entire code base in the context you're working on. And depending on the size of the monolith, it can even be difficult to load it into an IDE. The sheer volume of files and lines of code can make it very difficult to actually work on the code base. Obviously, with the size of the code base you're looking at, it's going to be much slower to build it, to run your tests, and to deploy it to production. You're very restricted in terms of the technology selection. You make your technology choice day one when you start a monolith, whether it's Java or Node or whatever programming language, and you don't have any real freedom after that because you're building in a single code base. So you're building in that technology stack. And then when you find a part of your system is running hot and you need to scale it, you can't scale just that part. You have to scale the entire monolith. And that's not really very effective. So, in theory, microservices to the rescue. So what does microservices give you? It gives you great agility and flexibility to change. You're working with much smaller units of code that you can build, deploy, and ship independently. Smaller code bases mean less context for developers. You don't have to keep as much in your head. You're working with a smaller service that ideally is doing one thing and doing it well. It's a lot easier to understand the code base. With smaller components should come smaller teams. You don't have to have everyone knowing everything about the monolith. You can have smaller teams focused on certain areas of the different microservices. It becomes much easier to scale. You can pick the microservices that need to be scaled horizontally or scaled vertically and just scale them, leaving the ones that have low volumes of transactions at a much lower level of scale. And you can pick the right tool for the right job. So if you need to implement it in a typed language, pick a typed language. If you need a relational database, pick a relational database. If you need a graph database, or if you need a functional programming language, you have the freedom and flexibility with each new microservice to choose the technology that best fits your use case. But you don't get this for free. Microservices come at a cost, and as we've learned, they come at a fairly high cost. You're moving the complexity out of the code in the monolith and distributing across the microservices, but you're also building a much more complex architecture overall. You're moving from functions calling functions within a single process to inter-process and inter-service communication. Suddenly you have to start thinking about network overhead, HTTP buffers, slow responses. What happens if one service goes down and another service is calling it and the called service is unavailable? You can very quickly find cascading failures coming up through your system. But probably the biggest challenge with microservices is the shift in thinking and the organizational structures that you need to make. So Conway's law says that an organization will build software that mimics the communication structures within the organization. So if you have a large team all communicating together and you try and build microservices, you're going to have the same experience we had back in 2011. You're going to build another monolith. To truly do microservices and do them properly, you actually need to start looking at an agile transformation. You need to start looking at smaller teams with all of the skill sets needed to build and ship the microservices working independently of each other. And if you don't make that transformation, and that is a hard transformation to make, but if you don't start by thinking about the organizational transformation you need, you're going to be in trouble from the very beginning. You also need a massive amount of automation. You're suddenly going from one or two large components that are probably shipped infrequently and could be hand-carved for deployment. You go from that to 10, 20, 50, 100, 1,000 microservices. The architectural structures are simply too complex for a human to be able to manually deploy them. You need to automate everything. And they really are not a silver bullet. They're not going to solve all your problems. They're not going to fix everything. They work very well in certain use cases, but they're not suitable for all use cases, so you need to really make sure you understand what problem you're trying to solve before you decide whether microservices are what will solve them. So, a couple of words of caution before we move on. So a colleague of mine on a mailing list recently said this: microservices buzz is a lot like teen dating. You're doing it because it's exciting and everyone else is doing it. You don't really know what you're getting into, but you want to do it anyway. And by the time you figure out what it's all about, you're already in a committed relationship. So bear that in mind. Don't get caught up in the buzz. Slightly more controversial one from Martin Fowler, who would be considered quite an expert in the field of microservices. He says don't even consider microservices unless you have a system that's too complex as a monolith. Or start a greenfield development with a microservice architecture. And that's a hell of a statement to make. But when you think about the overheads and the work you have to put in up front to set yourself up to succeed with a microservice architecture, there actually is something to consider in that. So a final word of caution before we move on. If your monolith is a steaming pile of you know what, and you don't think carefully about how you're going to break it up, what you end up with is loads of little piles of you know what. Okay, so assuming I haven't scared everyone off doing microservices, a couple of kind of rules of engagement to think about when going after microservices. First off, vertical slices are the key. This horizontal tiers, not what you're going to do. You're going to take a piece of the system, you're going to split it out from your monolith from top to bottom, from presentation layer through API, through business logic, to data storage. You're going to take it all and split it out. How do you figure out how to do that? You follow the principles of domain-driven design and bounded contexts. And that's not a technical thing, that's a process thing, it's a people thing. It's talking to your customers, it's talking to your product folks, it's talking to your BSAs, it's talking to your engineers, and it's figuring out, what does my system actually do? What are the fundamental things that my system does, and where are the boundaries between them? Is it an online system? Your boundaries are product catalog, shopping cart, customer addresses. In our case, with a mobile application platform system, it's things like projects, mobile applications, back-end applications, zero-code applications. Each of these is a bounded context within the system. And until and unless you identify the bounded contexts, what you will find is services calling services, calling services, calling services. If you don't find those fracture points within the monolith and identify them correctly, you will end up with a mess of inter-service communication. And you really want to limit that, because inter-service communication is difficult, it's costly, you have the network overheads, you have the problem with systems going down, and you're basically just making things harder for yourself. Now, you won't be able to get away from inter-service communication altogether. The way you do that is you stick with a monolith. So assuming you do break up into microservices, you are going to find services needing to talk to each other. Typically, the first approach people take with microservices is HTTP and REST. If you go down that route, you have to code for failure. You have to assume that the services you depend on are going to be unavailable, they're going to be slow, that basically they're going to do everything they can to make your life a misery. So do not trust the other services. Use things like circuit breaker patterns to guard against services either giving slow responses or no responses, so that if a service you depend on goes down, it doesn't cascade the whole way back up to the user. And before you even start thinking about microservices, start thinking about distributed tracing and logging. So we've had a couple of very good talks in this room already today on Elasticsearch, FluentD, Kibana for tracing and logging. Start thinking about that stuff up front, because if you have 200 services, each of them deployed across 3 instances, that's 600 instances. If all of them are logging to their own log files, well, it's going to keep you up at night trying to find where things are going wrong. Okay, so we now get on to the actual purpose of the talk, which is the 10-step plan to breaking up the monolith. Steps 1 to 5 are your prerequisite steps. You do them before you ever touch the monolith. Steps 6 and 7 are the steps you iterate on to kill the monolith. And then 8, 9, and 10 are optional or follow-on steps that you need to consider depending on the complexity of your system. So let's look at each of these. Step 1, instrument. You have to understand what's happening in your existing system. It doesn't matter if it's a single monolith or if it's 4 components or 10 components, you need visibility into what's happening in the system. It can't be a black box. As I said, you need centralized logging. You need distributed request tracing, so something like Zipkin. And you need as much information about what's happening in the system at the moment as is humanly possible. You want metrics, you want analytics, you want alerting information when thresholds are crossed, and probably most importantly, you need information on API usage. Because as we start breaking up the monolith, we're going to start creating new APIs, and we're going to start routing old APIs to new services. So you have to have visibility into what's happening at the front door at the API layer. Once you have some instrumentation in place, you then need to think about an intelligent router, an API gateway that will sit in front of everything in your system. A single point of access for all inbound communication. So this router acts as a bulkhead between your clients and currently your Monolith and what will become your microservices. It acts as a central point where you can do things like gathering additional API usage, where you can start, as you move microservices out from the Monolith and you want to start rewiring old APIs that would previously have hit the Monolith to route them to the microservice, you can start doing route mapping and data rewrites. So typically when you implement a piece of functionality in a new microservice, you will do it with new APIs, hopefully cleaner, better APIs. But the request and response payloads will not necessarily match what your Monolith had. So the API gateway, the intelligent router in front, is used to transform the incoming requests for the old APIs and transform the data on the way back out so that you can continue to support your old APIs using a new microservice. Other things that you may want to do in there would be static file serving, caching, authentication, adding request headers, adding unique request IDs that would travel the whole way through the system, which will be used by your logging infrastructure, so that when things go wrong and you see that request ABC123 failed, you can go to your Kibana dashboard and you can query on that request ID and see through all of the microservices that hit and the Monolith what actually happened and where the failures were. Now, you're putting this thing in front of everything. If it goes down, everything is down, so it has to be highly available. It is a single point of failure. You need to think about that up front, and you need to make sure that it is as highly available as possible. So with your router in place, it's time to start thinking about versioning, because you're going to be moving a lot faster in a microservices world. You're going to be building services, you're going to be destroying services, you're going to be changing API versions. So think upfront about the versioning approach that you're going to use. What we found is that the semver, semantic versioning approach, works very well, the x.y.z. And with semantic versioning, it allows you to communicate just through the version numbers, whether or not you have a breaking change, a minor change, or a patch change. You then need to start thinking about the versioning that you're using in your public APIs. How does that map to the versioning of the microservices that you're deploying? If you make a change to a public API or you make a change to a microservice, how do you route requests for the old API to the new microservice? Do you have multiple instances of the microservices running, serving different versions of the API? Do you have conditional checks in your code of your microservice so that you can be backward compatible against your API? There's no one simple answer. It really depends on what your system is and what your use case is, but you've got to think about it up front, because if you don't, it's going to come back and bite you. So stop and sit down with your development team and figure out what your versioning strategy is going to be. And play through a couple of scenarios. How do I upgrade this? What happens here? How do we deprecate? Think through all of this. Come up with a plan and a process and actually write it down and make sure everyone's on board. Okay, so then the next thing we want to do is we want to come up with a template for our ideal microservice. If we're going to be building lots and lots of these, we don't want to be handcrafting them, hand-coding them. What we want is a template that takes all of the heavy lifting for all of the utility stuff that's not part of our business logic or our domain context and gives us that in a standard way for every service. So things like your centralized logging, configuration management, the request tracing, security, analytics, monitoring, service discovery. All of those things that every single service will need, database connectivity, all of that kind of stuff. Build that in a template and then generate instances of that template for each new microservice. As part of doing that, figure out an approach for API generation. So you have the template, you create an instance of it, and you want to start creating APIs for a specific microservice. Please, please, please do not write them by hand. Identify tooling and technology that allows you to do API generation. The reason for that is you not only want to generate your API, you want to generate documentation on your API. You want to generate stubs. You want to generate contracts that can be tested. You potentially want to generate clients that can be embedded into other microservices to allow them to call your one. So think about tools and approaches for API generation rather than going the route of writing them by hand. And then automate absolutely everything. As you start building the services, you're going to need more and more automation. And if you haven't really started thinking about the automation up front, you're basically going to find yourself grinding to a halt to go back and have to retrofit that stuff. So you need proper continuous integration and continuous delivery. You need visualizations. You need to be able to see the state of your system. As the number of services grows, it becomes more and more difficult to kind of keep in your head what's happening. So think about building out dashboards, the likes of Grafana or Kibana dashboards, for viewing and ultimately managing what versions of what services are deployed where and seeing the health and the state of them. Invest the time in being able to do one-click deploys into your test environments and into your production environments. And that's not just one-click deploys of an individual service. That could be one-click deploys of an entire product upgrade, which could be a suite of services. While yes, we can release individual services independently, and it's one of the big benefits that's touted with microservices, in reality, very often for significant new product features, you will be touching a number of different services, so you will want to coordinate the release of a suite of services into production. So start thinking about that, figuring out how you're going to automate that, how you're going to roll it back, how you're going to verify the deploy has gone out correctly. Invest time in tools for an operations team if you have a SaaS product, to allow them to manage what's happening, see counts of errors, to see insight into what's happening, logs, stats, performance, all that information that may be kind of more manual at the moment. You don't want to be SSHing onto a VM or into a container to run top to try and figure out what's happening. You need to start centralizing that stuff and invest upfront in the tools and the technologies needed to allow an operations team to successfully manage a microservice architecture. And make it easy to add new components. That's actually been one of our biggest barriers. We have a SaaS platform, and there's quite a lot of steps and processes that need to be followed to add a new component to the system. In terms of what user does it run at, what access does it need, where is it logs, how is it monitored. I think it's about an 8-page document our operations team have that you have to go through for adding a new component. You have to codify all of that. You have to make sure that it's as simple as possible to add new components, because if it's not, when you're under the crunch from your product team saying we need this feature, you're going to end up putting it into an existing service because the barrier to creating that new service is too high. That's how we ended up with our second monolith. We didn't invest in making it easy to add new components up front, because at the time we didn't realize that we had to. This is all lessons learned over this journey. Okay, so at this point, we're actually ready to start strangling our monolith. And what that means is we're going to apply what's called a Strangled Pattern, which is we identify a piece of functionality using our domain-driven design approaches, and our bounded context, we're going to identify a piece of the system that's well bounded, and we're going to re-implement it as a microservice. We're going to deploy the microservice. We're going to add route mappings to our router, to our API gateway, to start routing traffic to the new service. And all of a sudden, there's a piece of functionality in the monolith that's no longer getting called, or at least no longer getting called externally. Because as part of strangling, we need to think about, well, what happens to our data? Are we going to take the system offline for a while and do a batch conversion of data to get it out of the monolith's database and into whatever data store we're using for our microservice? Because remember, one of the fundamental principles of microservices is that it is a completely self-contained stack. It has its own data store. Microservices should not be sharing data stores with other microservices. During that initial period when you're translating or migrating data, you may make a decision to connect directly to the monolith's data store to suck all the data out and move it into your own one. That should be a really temporary, short-lived thing. And ideally, that code should not even live within the microservice. You should build a separate service just for doing the data translation. You may, for some reason, need to talk back to the monolith through some internal APIs to get access to pieces of data. That's okay too. This is the real world. I'm not going to propose a idealistic solution that won't work. You may actually have to talk back to your monolith for some of your data, but if you do, isolate those communication paths as much as possible, both on the monolith side and on the microservice side, to make sure that when the time comes and you no longer have that dependency, that you can remove that code very easily. Deploy early and deploy often. Identify the first bounded context, split it out, and get it into production. Do not be tempted to try and change the monolith into a microservices architecture in one big bang. Because you try and do that, and the only thing you're guaranteed is that it will be a bloody big bang, and it will not work. Do not try and do that. Identify one piece, extract it, get it live, and iterate, iterate, iterate. This might seem like a little bit of a no-brainer, but we all know we don't do documentation very well. And why do we need good documentation in a microservices architecture? Well, one of the primary reasons is, as we move to microservices architecture, we're also looking at transforming our organizational structures. We're looking at transforming into a single large engineering team that does probably a waterfall-based methodology into much smaller teams that are operating using an agile methodology. And what that means is that not everyone is going to know very much about each microservice. And you don't want to have inter-person dependencies to understand how to interact with someone else's microservice. The service itself needs to have good enough documentation that one engineering team, one agile or scrum team, can use another microservice without needing anyone from that team to actually help them out. So you have to have good documentation on your APIs. Back to a point I made around templating, don't write the documentation, generate it. If you're relying on engineers to write documentation, you might as well go home now. So figure out an approach that allows you to generate the documentation in the same way and using the same tooling and approach that you use for generating your APIs. Make it as easy as possible to do API discovery. Consider using something like Swagger. And for anyone who has written Swagger documentation, it's another damn good reason not to write the documentation by hand. It's horrendous. But it's a very powerful tool. So if you can generate Swagger from some metadata that you put in code blocks with your functions, then you can make API discovery incredibly easy. Swagger provides some really brilliant tooling to allow service discovery of other services and actually interact through a Swagger console with the API in real time. At the same time, you're considering the generation of the documentation. As I said already, you're looking at generating clients that can be embedded into other microservices to make it as easy as possible to call. You're looking at generating mocks so that you can do isolated testing and integration testing between a small number of services without having to stand up the entire system, and stubs. If you do your documentation generation properly, you can actually do contract testing on your microservice almost for free. Excuse me. Yeah, there's a little bit of initial upfront setup, but once you have that setup out of the way and you have a process and you have tools in place for doing this generation, then you start getting a huge amount of benefits very, very quickly. Okay, so here's where it starts to get really fun. And by fun, I mean complex. So HTTP is a good starting point for moving from monolith to microservice. But at some point, I'm not sure exactly what the number is, probably 10 to 15 services, point-to-point HTTP communication becomes a bit of a bottleneck. You have problems with service discovery. So when you only have a few microservices, you can put in the host name of the service you want to talk to into the client service. As that grows, it becomes unwieldy and unmanageable. You need to start thinking about service discovery through something like etcd. If you're in a containerized environment, Kubernetes is using etcd behind the scenes to do that for you. Or you start thinking about moving from point-to-point HTTP communication to using, say, message bus technology. And it's at that point that someone will invariably start talking about event sourcing and CQRS. It's a whole other area of discussion that I'm not going to get into here, but suffice it to say, it's an area that you should do some reading in before you start on the microservices journey to understand what the different options are in terms of how services communicate, how you manage things like consistency, CAP theorem, eventual consistency. It becomes a lot more difficult to guarantee consistency and to do transactional programming with a set of distributed microservices. So if you have a strong need for transactional programming, then I would suggest moving this into your prerequisites and figure it out up front and make sure that the architecture and approach that you come up with for inter-service communication and sharing data between services will work for your business use case. So up to now, I've talked pretty much exclusively about from the API layer backwards. But what about your UI? It's kind of the elephant in the room, this big hulking monolithic UI. Possibly your UI is a part of your overall monolith. Hopefully not. But if it is, the first thing you're going to need to do, and this may sound counterintuitive based on what I said earlier on, but you're actually going to need to split the UI out into its own horizontal tier before you can start addressing it in a microservices architecture. With microservices principles, it says that everything for the service should live in the service. And that includes UI elements. So, that's okay, don't worry about it, sorry. So, how do you go from a huge monolithic tangled mess of UI code to a modular UI? You need to start thinking about frameworks that make it easy to plug components together. Things like Angular and React have some very nice models for encapsulation of functionality within components. But that's a big, big step. And it's kind of at this point that you'll be asking yourself, is the juice worth the squeeze? Am I happy to have the one remaining monolith of my system be my UI? And the answer might be yes. It may be a case that you know that there's a major UI refactor or re-architecture coming up for some other reason. Use that as the springboard for moving your UI into a more microservices approach. That is a big, big undertaking. It's a big technical undertaking, and it can be hard to justify to your business people what the return on investment there is. Unless your UI is in a state where the business are crying out for improvements, and you can use that as a kind of a leverage point to move to a more modern technology that supports putting the UI elements into the microservices, you're probably going to find this one as quite a hard selling point when you're talking to your business folks. So final thing then to think about is how we actually deliver software, both how we deliver it to the clients that are using our platform and how our engineers become more and more efficient at delivering microservices into the wider ecosystem. So, drawing on some of the experiences of Netflix, when they first started going down the microservices route, one of the first things they did was they put in this API gateway. And it was a generic API gateway that all of their clients used. And as Netflix started offering more and more services across different devices and different device types, they realized that a single API gateway just didn't work. Because you were trying to cater for the needs of many different device types, needing different data, different processing power on the client side, different communication protocols through a single API gateway. So what they did was they split the API gateway into multiple smaller gateways targeted at the actual clients that are using them. So if you have only one type of client, if you're only serving a web application, you don't really need to worry about this. But that's very rarely the case these days. You will likely have at least web and mobile. You may have some form of a native desktop application. You may be playing in the IoT space. You're likely going to have more than one client wanting to consume your APIs. And once that number starts to grow, probably beyond 2 or 3, or you find yourself putting more and more conditional checks in your API gateway to satisfy the needs of the different clients, it's time to start thinking about breaking down the API gateway into a set of smaller gateways that are targeted at those specific clients. Then in terms of what are our developers doing? So initially, small number of microservices as we're going through the strangulation approach, and we're strangling our monolith, we start with a small number of microservices. You can run them all locally. As that number grows, and depending on the size of your system, you're quickly going to find that a developer setup, a local development environment, becomes an arduous, problematic process. You're onboarding someone for 3 weeks just to get a development environment set up because you have so many moving parts. At that point, you want to start thinking about pushing most of your microservices onto a remote hosted PaaS. Something like OpenShift, for example, is a very good approach there. And then introducing inbound proxies that allow you to pull just the pieces you're working on locally and develop on them locally with the rest of the system hosted. Makes for a much simpler, cleaner, smaller, easier development environment. And then once the piece of development is finished and you commit and it triggers all of that nice automation and CI/CD stuff you have and all your good testing, your build passes, it automatically deploys that into that shared hosted environment, and then everyone else is able to pick up on your work with pretty much zero communication needed. So, in summary, it ain't easy and it's going to take a lot of time. There's a huge amount of upfront work required if you want to succeed. You're looking at months of upfront work, thinking, talking, building, engineering, to set yourself up to succeed. If you don't put in the upfront work, if you just jump straight in with 2 feet, like we did, you will have the same results we did, which was more monoliths. The complexity that it's quite easy to visualize within the monolith doesn't disappear when you break it up into microservices. It just moves. You put a little bit of complexity into each microservice, and you put quite a lot of complexity into the overall architecture. they're not a good fit for everything. If you're going to go down this route, don't do it because it's teen dating. Do it because you actually need to do it and you understand why you need to do it. And finally, and probably most importantly, you will need to change your organizational structures if you want to succeed. You will need to look at linking Monolith to Microservice linking Monolith to Microservice with Waterfall to Agile. And if you miss that step, then a lot of the rest of it probably doesn't matter very much. And that's it. So, if I haven't scared everyone off, do we have any questions? Yes?
Have you tried using with your microservices? You have a lot of APIs to communicate. Have you tried to use GraphQL instead of REST API?
Sorry, have we tried using
GraphQL. It's another type of API.
GraphQL, did you say?
GraphQL.
No, we have not. I'd be interested to hear a bit more about that, though. So we might have a chat afterwards. Okay, so I've either put everyone to sleep or made everyone so depressed about microservices that there's no questions. Yes, thank you.
Yeah. Do you have any tips on how to detect that your development drives into the direction to getting another monolith instead of your distributed services?
So the question is how to detect that your development patterns are leading you towards another monolith.
Yes.
Your team structures, your organizational structures. Basically, if they're not set up for a microservices approach, then you're not going to end up with microservices. So if you're not looking at breaking a subset of your development team out into a small team to focus on building a microservice or a couple of microservices and then repeating that pattern over and over, the agile transformation basically. If you don't do that piece, then that's a pretty good indicator that you're not going to be successful. I mean, there's obvious things like the number of lines of code in it, the size of it. Is it doing more than one thing? Is it crossing those boundaries of context within your system? And only the creators and maintainers of the system can identify what the boundaries are. So if you see what you thought was going to be a microservice crossing boundaries, then you're heading down the route of a monolith again.
From team structure point of view, do you, like, from what you said, it's obvious that there are lots of engineering work and releasers work inside one, like, team which builds microservice. Do you have somebody who is doing this, like, I don't know, build engineer inside team who is helping team to set up all this process?
Okay, so the question was, there's obviously a lot of tooling and building required. Do we have a build engineer within each team to set up the build process? Typically, the approach we use is, we have teams of about 6 to 8 people, usually 4 or 5 engineers, 1 or 2 quality people, and 1 kind of operational mindset person. But we also have a separate team that's solely focused on tooling and automation, on providing the underlying foundations, on making sure our CI/CD functionality is working the way we need it, on the templating that's needed for creating the microservices, on the operational insights and dashboards that we need for deploying. We have a dedicated team that is responsible for a lot of that support work. And then we have the right skills within each of the smaller microservice teams to be able to build on top of what that tooling team provides. Okay. Yes?
Are there any tools, or are you using any tools that are testing your microservices landscape, or all those, like Netflix is using chaos marketing? Is there anything like similar like that?
Okay, so the question is there any particular specifically test tooling?
Yeah, to test the availability or the structure.
So is there any specific test tooling that we're using to help test the microservices? I guess it depends what level of testing. Unit testing, integration testing, contract testing. Sorry? Availability? Is there any particular testing tool we're using for availability? No. We have talked many times about the, I don't know, is it Netflix, the idea of the chaos monkey testing, where you have a tool that goes and randomly kills services. The system is not quite ready for that. We're going to get there, but at the moment we rely more on monitoring, automated monitoring and automated deployment, rather than something as aggressive as chaos monkey type tooling that's killing processes. Yes? Sorry? Which use cases aren't suitable for microservices? That's a very good question. I don't have a very good answer. Sorry?
20 years old application and almost no developers from initial stuff.
Yeah. It's probably easier to ask which ones are suitable for microservices. And typically, it's if you're hitting a point, and in particular in our use case, if you're hitting a point where developing and maintaining in a monolithic code base is slowing your productivity down to such a pace that you can't ship features and functionality, you're missing deadlines, quality is suffering. When the size of your monolith grows beyond a certain point, you need to start looking at breaking it up. And that would be the kind of primary trigger that I would suggest that people think about in terms of when to adopt microservices. Because unless you have a lot of money behind you and a very, very understanding business owner and product manager, they're not going to want to have you invest the time and energy and money in setting yourself up for microservices architecture for greenfield. It's typically when you hit a point where productivity has dipped because of the monolith that you start looking at maybe this is the right time to look at a microservices approach. And if the organization is open to the change required to do it. Okay, so we have time for one more question. Yes? One big QA team. So our QA team is fully integrated into our agile teams. So each team is testing the services and the components that they're responsible for. We do still do product releases. We do synchronize the deployment of services. That's something that we still need to get away from. And typically when we are doing a product level release, the teams that have been responsible for the feature development in that release will come together to do the end-to-end product testing. So you need to have the QA folks fully integrated into the teams and working directly with the teams on the microservices. The kind of throw it over the wall approach is simply not going to work. Yes, exactly. Exactly. No? Okay, we're done. Thank you very much.
Very nice.
Unmute. Test. Better. Yeah.